Alright, I need you to pause real quick. I need you to pause. I need you to tell me one thing. I want you to think about this. Don't yell it out. Don't raise your hand. Just want you to think in your head for just a second. If I say 3 to the negative 1 power, evaluate that in your head and think about what that would give you. Just think for a second. Hey, Miss Harding, would you let Tristan go to the restroom? She's ready for you, man. All right, what is 3 to the negative 1 power?
1/3.
All right. So would you agree if you have the base of 3 raised to a negative power, it's equivalent to the base of 1/3 to a positive 1 power? Would we agree with that? Hopefully after today's discussion, this feels like it's true. If not, man, I'm really, really bombing as a teacher, right? So looking at this, which function, 1 through 4, has 3 to the negative exponent power?
3.
Option 3. And which one corresponds with it being 1/3 to the positive power? Option 2. Now, we just said, would you have given the same answers as the last time? And it looked kind of like it was freaky, right? Now, here's where we haven't spent as much time, but I want you to see the connection. So, if I do 1/3 to the negative 1, what is the reciprocal of 1/3? 3 over
1.
to the positive 1, right?
Yeah.
So would this help you understand why 1 and 4 are equivalent? Alright. Okay, it would never be the same number twice, okay? Who can tell me a little bit about the probability? Let me hear from Aaliyah. I want to hear from everybody as much as I can.
Well, the probability, we said it could only be up or bottom. That was like a 50-50 chance. Like, it could only be either one. Like,
Okay?
yeah.
Alright, so looking at this, do you remember the function that we used to model this? Or back then it was an equation because we hadn't talked about Unit 3. But how could we write an equation or a function to model this? Raise your hand if you think you know. Cayenne's the only one who knows how to write an exponential? I got a few more. Max, not sure. Cayenne, talk to me. What are you thinking? Like that? Yeah? Agree or disagree? Raise your hand if you agree with Cayenne. Raise your hand if you agree with Cayenne. Raise your hand if you disagree with Cayenne.
Let's say neutral one.
What? He says, wait, he's refining it. He says, wait, let's plus 100.
Wait, no, that's
Sarah, ask Cayenne your question.
That's like, but then if you did an exponential, just the opposite. You're basically you're halving it. So if you were to halve it, how would you halve it?
Yeah, so it would be a second.
Hold on, raise your hand. Wait, I wanted you to respond to them, but we have to hear each other. Kaja, talk to him.
Oh, because since you're having it, that's exponential because you're not going like at a constant, or you're going at a constant. Anyway, the equation will be 1/2, 100, and then 1/2 will be in parentheses to the x power.
To the what?
To the x power.
Hey, Aaliyah, bonus point, or I'm going to give this class point. What was that vocab you were just talking about, making a connection to what this does? What were you saying?
Asymptote.
What about it?
I said, like, if there was going to be a exponential graph, and we're going to put plus 100, that would be the asymptote. So it would never hit 100.
Agree or disagree, Cayenne? So, do you agree now with Kaja's version? Would you like to refine yours? Keep Kaja's. Who can tell me what is wrong with the function on the left versus the right? A new volunteer. Love these. Y'all are killing it. Let me have those gentlemen step it up. Christian, you raise your hand or no? Okay? Jacob, tell me, what's the difference between these two equations?
On the first one, you're multiplying by 100. On the second one, you're adding.
And what does that 100 represent here? What quantity? The y-intercept, but in the context of the M&Ms, it's our starting value, right? We started with 100 M&Ms, and then we agreed that this relationship of it halving, right? That half-life relationship. Here, I think you were thinking linear, where you added your y-intercept. Okay, I just want to point that out. Okay, I need, what was our goal today? raise your hand if you can tell me why 1 is equivalent to 4. I want to hear some of that good math vocabulary like REC. Think about what that vocab is. Emma, talk to me.
Okay, so 4 is turning the fraction into a whole number, and with 1 it's not really changing the whole number, so that way it's like both the numbers are going to be whole numbers.
Who understood what Emma just said? About half of us. All right, Christina, can you re-say what she said in your own words?
Like, 1 is equivalent to 4 because, like, 1/2 by any negative number will turn it back to a whole number. And 2 by any positive number will make it any whole number. So it's basically the same thing. So that's why I understand.
Raise your hand if you understood Emma or Christina. If you got at least something out of both of those, okay.
Can we
All right.
plug in a number, please?
Plug in a number?
Yeah.
Absolutely.
Can we do 1?
What number would you like? 1?
3.
All right. What's 2 to the first power?
2.
What's 100 times 2? All right, so this is f of 1 when we plug in 1. What about, what's 1/2 to the negative 1 power?
200.
Remember, flip the what?
That's right.
What's that vocabulary?
Reciprocal.
We gotta flip that reciprocal because it's a negative exponent. So this is equivalent to 2 times our y-intercept, 100.
Okay, that's what I don't get is that negative
why did you say
1/2 to
two and
negative
then
x.
flip
So whenever you say negative 0.5 to negative 1,
Yes.
and then 0.5 to negative 1, isn't that 1 over 0.5?
Hold on, let me think about this. 1, wait. You're saying 0.5 to the negative 1, which is the same as 1 over 0.5. But do we usually write fractions as decimals? Fractions with decimals? Is this the most effective means?
But is that like even real?
But can you do it like that?
Nobody mathematically would really write it this
Yeah,
way.
because it was like saying 1 over 1/2.
1 divided by a half. What's 1 divided by a half? What's 1 divided into half? If you take a whole candy bar and you break it into groups of halves.
And that's what I really get.
Hold on, wait. If you
Then
take
I have
wait. If you take a whole candy bar and you break it into groups of halves, wouldn't you agree that this is half and this is half? So how many groups are there? So this is equivalent to 2. So it's the same. But we don't usually represent it. Hey, do me a favor right now. I need one person at your table to go to Google Classroom and open up the closer. It is the recap app. Go to Google Classroom, open up the closer.
Okay, guess nobody's doing it. Yep.
Hey, I need you to silently listen up, please. Whew. Here's what I need you to do. At your table, you pick one person. They're going to record like REC. Think about what that vocab is. Emma, talk to me.
Okay, so 4 is turning the fraction into a whole number, and with 1 it's not really changing the whole number, so that way it's like both the numbers are going to be whole numbers.
Who understood what Emma just said? About half of us. All right, Christina, can you re-say what she said in your own words?
Like, 1 is equivalent to 4 because, like, 1/2 by any negative number will turn it back to a whole number. And 2 by any positive number will make it any whole number. So it's basically the same thing. So that's why I understand.
Raise your hand if you understood Emma or Christina. If you got at least something out of both of those, okay.
Can we
All
plug
right,
in a number, please?
plug in a number?
Yeah.
Absolutely.
Can we do 1?
What number would you like? 1?
3.
All right, what's 2 to the first power?
2.
What's 100 times 2? All right, so this is f of 1 when we plug in 1. What about, what's 1/2 to the negative 1 power?
200.
Remember, flip the what?
That's right.
What's that vocabulary?
Reciprocal.
We gotta flip that reciprocal because it's a negative exponent. So this is equivalent to 2 times our y-intercept.